So this is a topic on 3D Pythagoras and 3D trig. Okay, the best way to have a look at these kind of questions is that you always kind of look at the ground floor. Call this the ground floor over here, and then you've got the top floor. And generally, what they like to ask is either they'll ask you for the missing length or the value of the length, or they will ask you for the angle. They love it when you try and look at questions where you grab a corner and you try and stretch it to another part of the corner. So you're basically going from the ground floor to the top floor. In this question, we've got some values. Let's fill them in. AE, which is this height here, is 4. AD, which is 5. And DC, which is 8. So the first thing that we're going to do is this. We're going to work out, if I take this ground floor here, we're basically going to work out the diagonal from A to C. So this length over here from A to C. So if you look at it, we technically have a right angle triangle. There we go. So there's my 5 and there is my 8, and I need to then work out what my diagonal is from A to C, or I'll call it X in this case. We can use Pythagoras' theorem because, as we know, in a cuboid, all the corners are 90 degrees. So therefore, it ends up being x squared is equal to 8 squared plus 5 squared. Therefore, x equals the square root of 8 squared plus 5 squared. Once we've got the diagonal, I'll put it in red. There we go. We can then take that diagonal and use the height in order to calculate the diagonal going from A to G, which is what they're asking us. So again, we're going to use Pythagoras' theorem. I'll use this in red. There we go. So we're going to use our height, which is 4. We're going to use the base over here, which in this case is our 8 squared plus 5 squared with the square root. So 8 squared, a bit bigger actually over here, which is better. So that is 8 squared plus 5 squared, the square root of it. Okay, that gave us the diagonal. And if I use that, and I use Pythagoras' theorem again, so if I do 4 squared plus the square root of 8 squared plus 5 squared, should have actually worked that out. Okay, but I square that answer and then square root the whole thing. That will give me my value from A to G. You can also, because you're using a double Pythagoras here to make it a 3D Pythagoras, you can say to get from A to G, okay, let's call that length D here. To work out what D square is, you can say that it is A square plus B square plus C square, because you're using 3 different lengths. So therefore, D square is equal to 5 square plus 4 square plus 8 square. And to work out the diagonal going from A to G, therefore D equals the square root of 5 square plus 4 square plus 8 square. And you should get the same answer. 10.2 centimeters. If we look at the following question here, it says the diagram shows the cuboid. AB is equal to 5. AE is equal to 6. And AG, this time they've given us the diagonal. Okay, that's our D square if you think about it. And that is equal to 12. So here we can work backwards actually. If you remember what we did last time, okay, we had a diagonal that was here. There we go. So that's the green line I'll just draw here. We have the height, which is from C to G, which is here. And we have our famous AG line over here. So that's 12. The height here is 6. So we should be able to work out what the green is over here. Let's call this X for now. So in order to do that, we need to do, because it's a short side, it's 12 square, take away 6 square, and then the square root. So we're working backwards this time because we've been given the 3D diagonal from the ground floor to the top floor. Once we work that out, 12 square, take away 6 square, and then the square root of it. So now that we know what x is, which is 6 root 3, we can then form the ground floor right angle triangle. If I draw that out in blue, so I've got a length here, there we go, that's my right angle. This here is 5, the hypotenuse is 6 root 3, and the diagonal over here is your line BC. This is BC. Now think about this, the question is asking you what is AD, and if you look at the diagram, AD is the same as BC. So if I work out BC, it is the same value as AD. Again, I can use Pythagoras' theorem on this. So it's going to be 6 root 3 square minus 5 square, and square root the whole thing. It's a takeaway because we're working out a short side. And if you do that, it should give you the value of BC, which is the same value as AD, which should equal to 9.11 centimeters to 3 significant figures. This next question, we're going to label our sides again. So AE is equal to 4, AD is equal to 5, and DC is equal to 8. So 3 sides that have been given to us, and we can use that in order to work out, which is the question changes slightly, is angle ECA. So watch what I do here. I go from E to C, so draw a line from E to C, and then C to A. So it's this angle here. The best way to do a question like this, once we know where our angle is, so it's from E to C to A, okay, is to kind of first start off working out that diagonal again, which was from A to C. And in order for us to do that again, we can use Pythagoras' theorem. There we go, there's our diagonal, our right angle triangle. We've got a 5 and an 8. So to work out the line AC, it becomes 8 square plus 5 square, and we square root that for our long side to work out the value of AC. You should get a value using a calculator of the root of 89. I won't break that up at the moment, I'll just keep it as root 89. Once you've got that, if you notice, that's the diagonal from A to C. We've got the height, which is 4. So I'll just redraw this. Here's our diagonal, which is root 89, which now becomes our base. I've got the height here, which is 4, and we've got the hypotenuse coming down here, which is your EC, and there's the angle that they want us to work out, which we're going to call X. So according to this, it's a right angle triangle. We're going to use trigonometry. The longer side EC is the opposite the right angle, so that's the hypotenuse. The side opposite the angle is the opposite, and the side next to the angle is the adjacent. And if I go around the 3 sides, I've got the opposite and I've got the adjacent, which means if I draw my pyramids, here we go, we can say that we've got O and A, so we're going to use TOA, so TOA, which becomes tan of X, because we want to work out what X is. O is on the top, so it's 4, and adjacent is root 89. You can write the numbers out if you want, but I'll just keep it as a surd for now. So therefore, in order to work out what X is, I'll just do this here at the top. Therefore, X equals tan minus 1, because we're working at an angle of 4 over root 89. Close the bracket. It should give us an answer of 23.0 degrees. It's 3 significant figures, that's why it needs a 0 there. So it's the same as doing your simple SOHCAHTOA as well, but remember, if you notice the last 2 examples, we started on the ground floor, we found the diagonal, and then we moved up to the top floor. Okay, same similar steps. The only difference was in this case, because we're working at an angle on this, therefore we've had to use SOHCAHTOA. Okay, this question over here tells us to calculate the angle of AFC. So we do kind of the same thing that we did before. We go from A to F to C, so it's this entire angle that meets here. In order to do that, the angle at the top, what we're going to do is we're going to have to draw out a couple of diagrams to kind of help us. Now, a really good trick to do this question is this. If you notice that this angle, I'll do it in red. The angle here that we have to work out is made up of two lines. The first line, as I'm just drawing it, is from A to F, which means I need a triangle that involves the line A and F. I'll use green for the next one. And it's got the line FC, which means I need a triangle that's got FC in there. Let's focus on the FC one because I need to know what that length is. Without that length, I can't try and work out any angle. So to work out the length of FC, here we go. I'm going to use, I'll do it in blue, FC, CD, and DF. I'm going to use that right angle triangle. So I'm going to draw this on the side. Here we go. That's the angle I actually want, the side I want, which is FC. I'll even label it F and C. Let's put D here. There's the right angle. That's 30 degrees. And that's 7 centimeters. So the reason why I'm going to work out the length FC is because the angle that I'm actually supposed to work out, AFC, involves the line FC in there to form that angle. So I need to work out what FC is. It's so important. We're going to use SOHCAHTOA for this. In order to use SOHCAHTOA, again, this is the hypotenuse, DF. The opposite is your X, and your adjacent is your 7 centimeters. We're going to circle the two sides, opposite, because I need to work out what this side is, and 7 centimeters, which is the adjacent. So using two pyramids, if you look at this, 1, 2. We're using adjacent and opposite, so we're using tan, so it's TOA. This time we've got an angle in there, so it's tan of 30. The opposite at the top is X, and the adjacent is 7. So if I take my hand and I cover X, it's then tan 30 times 7. This gives us a value of 4.04 centimeters. So what I'm going to do is just to clear this up. So look at that. I've just drawn this first triangle. I'll highlight it again. I'll do it in dark this time. So we use this right angle triangle. And the only reason why we use this right angle triangle, I'm going to use a red pen, is because I wanted to work out this length. The reason why I wanted to work out this length here, FC, is because that's the angle that's connected to the line FA. So the length FC is equal to 4.04. I'm going to clear the ink now. So can you see what I'm doing? I'm drawing a triangle separately to answer the first bit of the question. So this here is 4.04. You can round it to, I've done it to a few decimal places, or you can keep the entire long number. The next thing I'm going to do now is I'm going to use the line AC and D. Okay, so I'm going to use this right angle triangle here as well. So I'm going to use A, C, and D. I'm just going to redraw it. There we go. And we're going to label it. So A, C, and D. So that's 7 centimeters. This here is 10 centimeters. And therefore, I should be able to work out what the length AD represents. Apologies. This one's 10. And therefore, I should work out what the length AC is, which I'll show you in a second. We can use Pythagoras' theorem, so we're working at the long side. Therefore, it is 10 square plus 7 square. And if I square root it to work out the long side, I get 12.21 centimeters. So this length here, AC, is 12.21. And because it's 12.21, okay, watch what happens here now. I'm just going to label it, so 12.21. So the question is, why have I kind of labeled, why have I worked out the length AC if you're not sure? Just watch what I do here. I'm going to use dark pen. So AC is here, that's my 12.21. The height I'm going to use is 4.04, which I worked out. And if I connect the length of AF together, there you go. They said calculate the length of AFC because AFC is made up of those two lines. So I've got 4.04 and 12.21. Now if I draw the pyramid of that, there we go, turning it again into another flat shape. So I've got 12.21. My height, which I worked out at the beginning, is 4.04. And those were the two lengths. So this length over here, which was FC, and the length over here, which was AC. So I'll label it if it helps. So that's AC and CF. That helps me work out this angle here at the top, which was X, which was the one we've labeled here. I'll just put it in yellow so it shows you. the length here, which was AFC, so A to F to C, which made this angle, and therefore we can use SOHCAHTOA again. How do we use SOHCAHTOA for this one again? The length opposite the 90 degrees is the hypotenuse. The opposite is the one I've just marked here, which is 12.21, and the adjacent is 4.04. So again, we use two pyramids. I'll do it at the top because we're going to get to our answer now. So two pyramids here. And we've got A and O highlighted, so it's TOA, so TOA. Therefore, it becomes tan of x. The opposite is 12.21. The adjacent is 4.04. And guess what we do? We're going to work out an angle, so we need the inverse, okay, tan. So inverse tan of 12.21 over 4.04. And you should get an answer of 71.7 degrees to 1 decimal place. Just check that, please. But watch the steps that I did. So I found out what the angle was. I'm just going to kind of rewind this just quite simply. I'm not going to spend too long. So it said find the angle AFC. So A to F to C. So it's these two, this angle here at the top. The angle is made of this length here. So I need to know what this length here is. Okay, so I need to work that out. I also know that I have got this length here, FC, that I need to work out. Okay, so this forms the other triangle down here. So if I work out what this length here is, and if I work out what the length is here, the length here is, I can work out this length, okay, for this triangle here. There we go. So we've got the triangle FAD. So if I work out what FAD is, I can work out like this small part. If I work out FAC, I can work out the length FC, and therefore it makes that full angle over here. So I've broken into two triangles actually to work it out. Have a go at this yourself if you want by covering it and retrying it again, but we've used 3 triangles for this question. Okay, so for this question it says that the diagram shows a pyramid. The base of the pyramid ABCD is a square. So this here is a square, and as we know, the properties of a square are that the sides are all equal. They've said that AB is equal to 5. So therefore, if AB here is equal to 5, it means every side here, because it's a square, is equal to 5. The point E is 10 centimeters vertically above the base. Okay, so the point E up here is 10 centimeters. So the height is here to here, that yellow line, vertical line of 10 centimeters, which we'll come to in a second. Okay, so the question then says calculate the angle EAC. You should always mark it on. So E to A to C, so it's this angle, okay, over here, EAC, which I've just marked. I'll call it X for now so you can see it clearly. That is the angle that they are interested in. If you notice that the angle is made up of this line here, EA, and the line AC. So I'm interested in AC currently at the moment. So what I'm going to do is I'm going to take this square. I'm going to be interested in the line AC, and I'm going to make a right angle triangle. There we go. Doesn't matter which side I use, but I've got A here, C here, I've got the D here. As you can see, I'm using this bottom triangle here. And what I'm going to do is, because I know the square has 5 centimeters by 5, I should be able to work out using Pythagoras' theorem what the length AC is. So to work out what AC square is, it is 5 square plus 5 square. Therefore, AC is equal to square root of 5 square plus 5 square. Therefore, AC is equal to 7.07 centimeters. Okay, 7.07 centimeters. Just check that on the calculator. And that is the length of AC. Now you know what the length of AC is. This is a great question because this is where a bit of intelligence is used. That if I find the center of the line AC, I'm finding the center of that square. And if I know what the center is, I'll just mark it with a green, and I draw a vertical line going down. That is the vertical line, which is 10 centimeters from the base. So now I've got a triangle, I'll draw it in red, going down, which is 10 centimeters, which is going across. Now, if you remember, the line AC was 7.07, therefore this has to be 7.07 divided by 2. And then I've got the diagonal here, and that diagonal is my line EAC over here, so that becomes X. I'll just label the vertices, so that kind of tells you a bit more clearly what we're doing. Actually, this is not C, this will be the, let's call this the M for the midpoint of the line AC. So I've got my right angle triangle here. Now we get to use SOHCAHTOA, okay, because we use Pythagoras on the first bit to calculate the diagonal. So in order to use SOHCAHTOA, we're going to say, here's my hypotenuse, this is the opposite, this is the adjacent, so I'm going to use the opposite and the adjacent. So two pyramids again. Therefore, it becomes TOA, so tan of X. Remember, we're working at an angle, so we'll need to know the inverse tan. The opposite is 10, and the adjacent is the answer of 7.07 over 2. I expect you to do that on a calculator. So therefore, tan minus 1 is equal to 10 over your 7.07 over 2. Should do this on a calculator before you put it at 7.07 over 2. I've only done it to show you the steps. And you should get an answer of 70.5 degrees. Just have a check on that on the calculator. Next question that we've got here is calculate the size of the angle that AF makes with the plane ABCD. So here's the plane ABCD. And what we're looking for is the angle A. We've got the line AF. Here's the line AF. And so if I use the line for A to C, if I'm going through the plane, it's this angle in here. This is the size of the angle that the line AF makes with the plane ABCD. So I'm interested in this angle over here. In order to work out what this angle over here is, remember, the angle is made up of two lines. The first line is AC. Use a different color actually. Is AC. So I'm only interested in the green line, AC. And then we're looking at the line over here, which is AF. But we'll do it one step at a time. Or we start with the plane, the ground floor. Let's draw the diagram out. So we're taking the ground floor. I'll draw it up here, then we'll work our way down. 1, 2, 3. So we've got A. So you know which one I'm talking about. There's my C. There's my D, there's my right angle. We've got 30, we've got 20, and I'm interested in working out AC. So therefore, to work that out, call it x squared is equal to 30 square plus 20 square, and then square rooted. When you do that on the calculator, you should get an answer of 36.055 ... centimeters. We'll do the rounding later at the moment when it comes to 3 sigma figures. Main thing is just to kind of see how the diagram looks. So this is the line AC, and that is 36.055. So now we know what that is. I'll just put that on the side, 36.05. Yeah. So we're now interested in this triangle here, FC, CD, and FD. So I'm going to draw that triangle here for you. There's the right angle, there's F, there's D, there's C. So we've got 20 here. I've got 35 degrees here, and this time I want to work out FC. So we'll call this one here X. Okay, so this one has got an angle involved. It hasn't got two sides. That's given to us. Therefore, we're going to use SOHCAHTOA. So hypotenuse, opposite, because it's opposite the angle, and then the adjacent. We're using the opposite and the adjacent, so therefore we're going to use tan. If we're going to use tan, it's TOA, it's tan of 35, don't forget brackets. Tan of 35, the opposite is X, and the adjacent is 20. And if we take our hand and cover the X, therefore we end up with tan, bracket 35, close bracket, times 20. So we get an answer of 14.004 centimeters, which is your height of FC. So just to kind of show you where we are at the moment, I'll do it in red. We've got a height of 14.004 0.04. We worked out AC, the diagonal. There we go. And that diagonal was 36.005. And so therefore, as you can see, the question says calculate the size of the angle AF makes with the plane ABCD. So therefore, there's the AF that we looked at right at the beginning. This was the angle, and we've worked out two sides. So what am I going to do now? Here's my right angle again. That was 14.004, 36.005, and there is my X. I'll label the sides A, F, and then C. So again, we're going to use SOHCAHTOA. Here's the hypotenuse, opposite and adjacent. We're going to use the opposite and the adjacent, so it's TOA, so two pyramids again. So TOA, therefore it is tan of X. The opposite is 14.004. The adjacent is 36.005. Therefore, tan inverse, because we're working at an angle of 14.004 over 36.005. Close the bracket, and when you use a calculator, you should be getting an answer of 21.2 to 3 significant figures degrees. The last one that I want to have a look at is kind of similar to the one that we've kind of done two questions previous. It says the diagram shows a pyramid. The base of the pyramid is square. So again, we've got a square. AB is 15. So if AB here is 15, it means that AD is also 15, DC is 15, and BC is also 15, as it's a square. The question says calculate the volume of a pyramid. To work out the volume of a pyramid, we need to know the formula. So the volume of a pyramid is 1/3 multiplied by the area of the square. So the area of the square times by the height. Okay, so that's our formula. Make a note. So it's the area of the square multiplied by the height times 1/3 of it. So in order to work that out, I'll come back to it in a second. We can tell that the area of the square, so that's quite nice. There's a 15 by a 15, so that's nice. We just need the height, and the height is the one vertical height from P coming down to the center. So what did we do last time when we wanted the center? We knew that this square over here, ABCD, and if we work out the diagonal of AC, okay, and find the middle of it, we should be able to then work out what the height is. So let's do that first. So we've got a right angle triangle. Let's use A, C, and D. We know we have a 15 by 15. It's a right angle triangle, so we're going to use Pythagoras. So therefore, AC square is equal to 15 square plus 15 square. Therefore, AC is equal to, sorry, that's a bit rough. So therefore, AC is equal to square root of 15 square plus 15 square. Therefore, AC is equal to 15 root 2. But we want the middle. Remember, the middle we'll call M. So AM to the middle is equal to 15 root 2 divided by 2, which is equal to 10.6. So what we're now going to do is we're going to go to the midpoint from A to M. We'll work out what the height is, and then we can work out what the right angle. So A to M is 10.6. The height is what we need. We've got the angle PAC, so PAC here, which is 65. Therefore, here is 65 degrees. We use SOHCAHTOA again to work out the height. So I've labeled the hypotenuse, opposite, and adjacent. We need the opposite, and we've got the adjacent. We use TOA again. If I fill it in, we end up with tan 65 times the 10.6. So I get height of 22.7. Now that I know the height, which is 22.7, if we use the formula again, the volume is equal to the area of the square, which is 15 by 15, multiplied by the height. Don't forget, it is 1/3 of it. So 1/3 of the square times by 22.7, giving us 1706 centimeter cube.